All right, so business as usual. If you're watching this video, you've probably seen one before, and you're probably watching it to get some sort of credit, whether it be participation points or extra credit. Anyway, the situation is the same. Throughout the video, I'm going to give a series of words, attendance words or attendance phrases. You can write them down. Also, every time I do give one of those words, you are going to take a screenshot when I say it. And then at the end of the video, what you'll do is send me an email that includes all the words and all the screenshots, but also includes one question about the material covered in the lecture. So your first word for attendance is going to be outlet. If you see me pointing on my foot, that's a power outlet right down there. So I should see the first word will be outlet, and the screenshot of a video with me pointing at that power outlet on the wall. And that's it. And it is, let's see, 7:45, so you can skip ahead about 10 minutes, and then we'll be into the introduction section of the lecture. Morning. Savannah, right? Good morning. Edwards, right? Yes, sir. So we got less than 2 minutes. I'll start the redundant announcements again. Sorry to beat a dead horse, but you'd be amazed, even though I say this every other day, people still forget some of the stuff that I say every other day. So I continue to say them every other day. Anyway, these announcements are obviously for you guys, 101-02, but we do have other sections that are watching this. So when it comes to due dates and specifics about exams and labs and things like that, that's only for you guys. So if you're in any other section, you can disregard or at least ask me if there's something specific. Like what I'm about to say about the exam does not pertain to 101 online because you've already taken it. So yeah, only for 101-02 announcements. I'm sure you guys don't have any questions about that because in a sense I'm talking to the other people who are watching the video. So a reminder to check your emails and course announcements a lot. Technically, every time I post a course announcement, you should get an email for it, just in case. Like I'm saying, check your email, check your course announcements. As far as attendance is concerned, that's probably going to start becoming a little bit less important, knock on wood. So hopefully we're not going to have any more weather days, but just in case, you still want to check her. So any questions about that? Okay. Schaefer came in. There we go. Anyway, so as a reminder today that the lab we did on Wednesday is past due after today, so make sure you get it done. If you forgot something, didn't have the data, or you just forget what the data means, let me know. I can help you. I don't expect you to just magically memorize everything, so let me know if you need help. I can help you. Decipher the data. And speaking of the data, some other group put their data on the board and didn't erase it. So I'm not going to erase it just in case they still need it. But that's not our data. So don't take a picture of that and say, hey, I don't remember that. That was different. I better take a picture of it. Don't worry about it. That's not for us. That's for some other group. So, but anyway, yeah, Lab 4 is due today. I'm trying to think of some of the mistakes I've seen so far. But I could give you some advice. Maybe like make sure your hypotheses match the question. Right. So if it says, do you think sucrose is going to leave the cell? So it'll be wrong to say, I think water will enter the cell. That's a good hypothesis, but that's a different question. Two different questions for that. Of course, in that particular example, they're in the same question number. But anyway, make sure you watch out for that. Make sure you think about your math. For example, and I'm not getting, don't feel bad if you're the person who made a mistake. But I was looking at the percent change thing for the last sucrose experiment. And you guys remember, I think it went up from like 16-inch to 17-inch grams. Very small change. Someone put 100-something%. And I don't need a calculator to tell you that's wrong. That's the kind of like lookology is what I call it. You should look at your stuff and just think, does this make sense? Because if you say you went up 100%, that means it doubled, right? So or if it's even close to 100%, you're like, all right, that should be about double. Or if it's about 50%, it should be about half. So if we started at 16 and you tell me it went up about 50%, then I'm going to look for it to be increased by about 8, right? Because 8 is half of 16. So this is the kind of stuff I want you to think about when you're doing your labs. And again, I'm probably not going to break out a calculator and double check your math, but I'm going to look at it, and if it seems wrong, you're going to get it wrong. But as always, speaking of which, you can always make corrections to your labs and resubmit them to get your points back. And you can always meet me online so I can talk about your wrong answers, and you get a 5% boost to your grade. And I may have marked something wrong. You might be able to explain why you wrote that down and what you were thinking. And I'm like, oh, well, that was okay. And you might just get the full point back, right? Things like that. So any questions about Lab 4? All right. Again, there's no pre-lab due today. Hooray. Because next week, it's going to be nothing but a pre-lab lecture is all we're doing. It's important. So there will be no pre-lab that's due today for next week. All right, exam 1, like I've been saying, it's due Sunday. We know it now. It's due Sunday. Of course, you can already start it. Some people already have. You have 50 minutes to answer about 50 extra credit questions. It's closed book, so don't use your notes, don't use the book, don't use the internet, don't use ChatGPT, right? That's the point of a closed book exam. And you will not hit your score, like it won't tell you your score or anything until it closes. That's to help prevent cheating. And that also gives me a chance to go in, and I've already done this for some of you. I'm going to go look at every single question you missed and make sure it's not a glitch. And so far it has been, even though you haven't seen your scores, some of your scores have already increased a little bit because I found a glitch and fixed it, and your grade went up. So that allows me to be able to fix those things before you guys see your grade and be like, oh my God, why did I get a 68? And it turns out you got a 75, whatever the case may be. Anyway, excuse me, any questions about the exam? All right, whoa, it's already 8 to 3. I guess I closed the door. And again, to remind you, after the exam closes, I will reopen it up for you to retake it. You can retake it as many times as you want. You can use your notes and the internet and all that for the retake. It'll be untimed. And then you just tell me when you're satisfied with your new grade, and then I'll average your first grade with your highest grade, and that'll be that. So again, less pressure, I hope, to prepare for exam 1. So any questions about exams? This particular exam. All right. Next thing I'm going to start doing, I don't think I've said this before, but just in case I'm saying it again, I'm going to have a stack. I'm going to get more organized to make sure I don't repeat anything myself. But I'm going through my old student feedbacks, and I want to, like, if there's an issue from prior students, I want to address them with you. It's too late for them. It's not too late for you. One of them said, I'm hard to understand. No one has ever told me that. But that's something you've got to tell a professor. If you can't understand them, let them know, hey, I can't understand what you're saying. So if that's the case with me, please let me know. Also, if you were to write that down in a review, maybe be a little bit more specific. Like, is it my accent? Is it my volume? Is it the words I'm using? Either way, let me know, especially if it's the words. Because in biology, I might give you a definition. And in that definition, I might give you a bunch of other words that don't make sense. So if something doesn't make sense to you, let me know. If it's from the video, I'm like, oh yeah, because I've watched some of my videos, it is hard to hear because of the microphone. Sorry to say, you should just leave that out. Like, I do the best I can. I am doing the best I can. So this is an in-person class. I just happen to make videos like to be nice for people who can't make it. So please don't hold that against me if the video quality is poor when this is an in-person class and we don't even need video. But anyway, yeah, student feedback. So I'm going to make a thing of that. Go through them and bring them to you so you can know, hey, let me know how I can make things better for you, not just the future students. Anyway, any questions about me being hard to understand? All right, business as usual with attendance, right? It's mandatory, so I have to turn it in. Let me slow down though, because even though this is business as usual, some people still haven't caught on. I do have to turn in my attendance to the university that says they were here or they weren't here. That's separate because participation is also graded. So to get your participation points, at least if you're here in person, it'll change day to day. I'll get to that. But if you're watching the video, like it says right here, every time I say an attendance word, you have to write it down. You also need to take a screenshot, and then at the end of it, send me an email with all those words and the screenshot and one question about the material. If you're live streaming, which I don't think anyone is right now, but just in case, it's the same situation except you don't need screenshots. If you're in person, sometimes you do have to do all that, obviously without screenshots because you're in person. But for today you can just send me an email with just one question. But make sure you send the email because I have some people who have been present but have gotten 0 participation points because they're not following the participation instructions. And that says something, right? This is why I do this, because I say this every day, yet the same people are not doing it. So they're here, maybe they just haven't woken up yet. And I get it because I'm still waking up too. So I don't mean that in a derogatory way, but some people are just sitting here and they're here, but they're not participating. So make sure you do that. Any questions about any of this? All right, good. Let's jump into it. Wait, let me do official attendance since we're recording. Ashley is not here. Barrett is here. Wooten is not here. Trahan is here. Dickens is not here. Clark is not here. Inca is not here. Isaiah is not here. Smith is not here. Watson is not here. Haley is here. Lucas is here. Marley is here. Noah is not here. Savannah is here. Leah is here. Edwards is here. Wilkes is not here. Did I miss anybody? Okay. So that was a pretty long introduction. It was sort of on purpose because This will be a very short lecture. I'm not going to jump into chapter 4 because this is the end of what's going to be on exam 1. I'm just going to let you marinate on that. Anyway, the first word for attendance is going to be video. Circle it right there. So again, if you're watching the video, the first word is video. Well, second for you, but this word is video, and I've circled it, so there should be a screenshot showing that I circled the word video. Anyway, the last thing we were talking about was we were talking about active transport, right? So we're talking about diffusion in general and things moving around in and out of a cell. First thing we talked about was passive transport. We talked about diffusion and different versions of that, where things just naturally go from an area of high concentration to an area of low concentration. Then we left off talking about active transport, which is where things go against their concentration, which is very important for life, not necessarily for the exam. There might be a couple of questions about it, but for life, it's very important because we need to push things against their concentration gradient. And there'll be some great examples of that starting in chapter 4. So for now, I'll just leave it at that. And the very last thing we said was one of the things that causes this imbalance is an electrochemical gradient. And I mentioned to you that you do not need to know that. It's in your textbook, which is why I'm bringing it up. That way, when you're studying your textbook, you can remember, oh, he said that there's going to be no questions about this. So I'm addressing it. It's there, but there's going to be no questions about it. All right. If you download the PowerPoint, you can watch this little animation of active transport. It gets pretty specific. This is a very specific. This is not a hypothetical example. This is a real example. You know, usually, so far, I've just shown you these examples, these little colored balls. They did not have a name. This one actually has a name. This is called a sodium potassium pump. So what's happening here, and again, if you download the PowerPoint, you can see it in action, but you can tell by looking the way things fit, right? The sodiums are going to fit there. Those potassiums are going to fit that little jagged part. And basically, it's going to let things into it and then spit it out, right? So that's how active transport works, right? And like we said previously on Wednesday, didn't say it yet today, but this requires energy. That part's not being depicted in that picture, so you can't see the ATP giving it energy. But here you can see it in this picture. ATP provides the energy, and you'll learn more about ATP in the next exam. But it provides the energy for that thing to change shape. That's basically all it's doing, right? Right now it's open to the outside anyway, to accept this solute, right? Well, actually, it's doing it the other way. In this case, it's going from here. No, it is. Yeah, it's going from here to here. Right? Lower solute concentration to higher solute concentration, which is against diffusion, right? It's going to take energy. It's passive transport. So again, ATP gives this thing the energy. Once that goes in there, it has then the energy to change shape. Then once it changes shape, it brings in that solute, whatever it may be. So again, it's just all about changing shape. So once again, this theme of function, shape, and function, right? And in this case, as usual, it's going to take energy to make something change shape. It's going to take energy to make something go against this concentration gradient. And this is very important. It's a great way to end off the first portion, exam 1 stuff, because once we get back into it on Monday, when we start working on exam 2 stuff, almost entirely, exam 2 stuff is all about energy. How do cells get energy? How do cells use energy? What are the different types of energy? How is energy being converted? All these things. So this is a very important concept as far as that's concerned. As far as exam 1 is concerned, it's very important. But this idea of energy is a great introduction. All right. Any questions about that? Okay. So again, we're talking about regulating what comes in and out of a cell. We've talked about diffusion or passive transport, right? That doesn't require energy. This is when things go from a higher concentration to a lower concentration. We talked about that on Wednesday. Today, we just finished talking about active transport, where we're pushing things against the concentration gradient, which takes energy. Now we're talking about something completely different. Now we're not necessarily talking about diffusion or anything going through the plasma membrane, because that's what we've been talking about. Now we're talking about bigger stuff. We're talking about moving a lot of stuff at once, and this is called exocytosis and endocytosis. You will need to know the difference, maybe for exam 1. If not for exam 1, definitely for exam 2. But it's pretty simple. It's kind of in the name. So even though if you've never seen these words before, I bet you can guess which one is which, right? One of them is moving things out of the cell. One of them is bringing things into the cell. Exocytosis is things going out. Endocytosis is things coming in, just like the name's kind of things. Anyway, endocytosis. This is technically a type of active transport, For the exam, I probably won't even get into that, but yes, this does require energy. And yes, very often we could be going from an area of lower concentration to a higher concentration, so going against the concentration gradient. But there's two types, so make it a little bit trickier. Two types of endocytosis. One of them is called phagocytosis, and the other one is called pinocytosis. Does anybody know, like if you're not in a biology class, like for your biology, for example, if I said for Valentine's Day, I'm going to get my wife Pinot Noir, or maybe it's the Pinot Grigio, what am I saying I'm going to get her? A wine, right? A wine. Yeah, Pinot Grigio is a white wine, right? So that's how I remembered it when I was a student. Pinot reminded me of wine, so I just remember that was drinking, cellular drinking. That's when the cell brings in some sort of liquid. And by a process of elimination, the other one was cellular eating, which is bringing in solid stuff. So there you go. And that's basically as far as deep as we're going to get. In a sense, this is almost very unimportant for this semester because once we move forward past this chapter, we are definitely still going to talk about diffusion and active transport. But if I remember correctly, we never really come back to phagocytosis or pinocytosis. But it happens, and it's important for your life, like at the cellular level, this is important. But academically, it's not important because, again, very little on the exam, if at all. And again, you do not need to understand it moving forward to understand the other material in this chapter, obviously, in this semester. So yeah, but we did see a picture of this earlier when we were talking about the different parts, when I was flying through the different parts of a cell, and I was talking about a vesicle. And I tried to explain what it is. And this is a better picture that kind of shows what it is. Here's the vesicle. So what happens is something that comes in to the cellular membrane, and it just kind of engulfs itself around it and pinches itself off. So in a sense, that's almost like its own little cell. Right? It's got a cell membrane. It has probably some cytoplasm in there. Of course, it's not really a cell because it doesn't have all the organelles, but it is a little round cellular membrane thing that has stuff in it. So in that sense, it kind of is. Anyway, that's endocytosis. Any questions about that? All right. The next one. Keep a close eye on that picture because the next one's going to blow your mind. Not really. It's basically the opposite. Here we have a vesicle, right? And it is now attaching itself to the cell membrane so then it can, release what's in it. It's just stuff leaving the cell. For some reason, whoever decided to differentiate between pinocytosis and phagocytosis did not do the same for exocytosis. So when you're getting stuff out, we don't care if it's solid or liquid. But yeah, that's exocytosis. The next word for attendance is going to be color, and it is purple. Those little purple drops. Probably saw you, but I'm going to tell myself those are little droplets of rain. So I'm going to call that purple rain. But you're free to imagine whatever you want. It is. All right. Anyway, any questions about exocytosis? All right. If you download the PowerPoint, you can watch this little video. This shows pinocytosis in action. And that is it for the day. I told you to be quick. Does anybody have questions about anything about chapter 1, exam 1, anything like that before we go? Like I said, it's an early day. All right. Well, if you come up with a question, I will be in my office and online at least until 10 a.m. For those of you who are here, don't forget to send me the email with at least one question. You can also send the words. But either way, you guys are going to get a little extra credit just for being here because it was a really short lecture. But hey, thanks for coming in for almost nothing. So because of that, you'll get some more participation points than usual. Not a lot, but it all adds up.